Welcome to True Projects. In this video, we are going to explain about the project, which is robust and lightweight data aggregation with histogram estimation in edge cloud systems. So before getting into the execution, first let's understand what is the project about. For example, in a smart grid system, IoT devices such as smart meters they collect extensive data on energy consumption patterns. This data is sent to cloud servers for analysis, which helps to optimize energy distribution and also usage. While these insights are beneficial for users and service providers, they also raise privacy and security concerns. So they raise privacy and security concerns. And also, the cloud servers might access the sensitive information about the individual usage habits. So, to address all these issues, secure aggregation methods have been developed to encrypt user data before it is transmitted to cloud servers. This ensures that the personal data remains confidential and also secure from unauthorized access. But many existing solutions such as homomorphic encryption methods, they come with the high computational costs and also inefficiencies, which makes them less suitable for resource constrained environments typical of IoT devices. This creates a challenge. How can we protect user privacy while still allowing for efficient data analysis and aggregation? Moreover, in IoT networks, users often experience disconnections due to unstable network conditions. This not only affects data transmission but also complicates key recovery process, which leads to the significant communication overhead. When users disconnect, the effort required to recover encryption keys also increases, which can slow down overall system performance and also efficiency. Moreover, many existing systems secure aggregation schemes fall short in supporting complex data analysis tasks such as histogram estimation. This capability is crucial for applications like traffic flow management and also the energy usage optimization, where understanding patterns in the data can drive better decision making. Without effective means to conduct such analysis, the potential of IoT networks to provide valuable insights is hindered, ultimately limiting their effectiveness in delivering smart services. So, to overcome all the challenges outlined, this project presents RLDA scheme, which is nothing but robust and lightweight data aggregation. This enhances both the data privacy and also the analytical capabilities in IoT environments. This scheme offers a secure and efficient method for data aggregation in edge cloud environments by offloading key generation and recovery to edge servers. So this approach simplifies the encryption and also the decryption process and reduce the burden on cloud servers. So when users they disconnect to RLDA scheme, it facilitates key recovery through edge servers. So this facilitates key recovery to edge servers, which significantly minimizes the overhead. Additionally, it supports secure histogram estimation, allowing for the advanced data analysis while ensuring the privacy of sensitive information. Overall, this RLDA scheme optimizes data handling, enhancing both efficiency and security in IoT applications. So in this project, two algorithms play a crucial role, which are poly REC aggregation and CRT REC aggregation. So what is this poly REC aggregation? It is engineered for speed and efficiency. It aggregates encrypted data into a single value. So this encrypts the data, it will collect the data into a single value, allowing the cloud servers to quickly decrypt the information. This approach is particularly advantageous when handling large data sets as it optimizes processing time without sacrificing computational efficiency. Essentially, it ensures that the data can be decrypted and also analyzed rapidly, which is vital for real time applications. So, coming to this CRT RAC AGG, that is aggregation, it is a Chinese reminder theorem based recoverable aggregation, which focuses on detailed decryption. This algorithm breaks down the encrypted data into smaller and manageable parts that can be decrypted individually. By doing this, it allows for a more accurate reconstruction of the original data, making it especially useful for applications that require precise analysis such as traffic flow management or energy optimization. So together, these algorithms enhances RLDA scheme by ensuring that the data aggregation is not only secure but also efficient and capable of supporting detailed data analysis, ultimately improving the overall functionality of the IoT environments. Moving on, as the extension, cache memory is incorporated in this project. It serves to optimize data processing and reduce the resource consumption. User data is temporarily stored in the cache where duplicate values are identified and removed before transmission to the cloud server. So, this extension is introduced to reduce the redundant data transmission, thereby lowering cloud storage usage, cutting operational cost, and conserving energy. By streamlining the data handling through caching and deduplication, it enhances the speed and efficiency of data aggregation and analysis at the cloud. So, this is all about the theoretical concept of the project. So, to implement this project, we need some basic requirements. So, backend languages which are used are Python and JavaScript. Framework used is Django. Front-end languages used are HTML, CSS, JavaScript, and Bootstrap 4. And databases MySQL. And hardware requirements are processor of i5 and above, RAM of 8 GB and above, and ROM of 20 GB and above. So now let's execute the project. To execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Let's understand each of them. How will they be used in the project? So coming to this first folder, which is RLDA, inside this folder, there are Python code files that will be intended to be dynamically loaded into the project code during runtime. And in this RLDA app folder, it comprises of two subfolders and some Python code files. And those two subfolders are nothing but static folder and also the templates folder. Coming to static folder, in static folder we will have all the CSS, JavaScript and Bootstrap files. These files they contribute to the visual and interactive aspects of the application. And coming to the templates folder, within this folder we will find all the HTML pages used throughout the project. It includes pages like index.html, home.html and more representing various sections of the website. And Python code files they will be executed during the runtime of the application which supports the project's functionality. And this is manage.py file. It is a command line utility that comes with a Django. And it provides various commands for managing Django projects, including tasks like running the development server, creating database tables, and applying migrations, and more. And this is the run.bat file. Instead of executing the project through command line interface, we have created this run.bat file. Now we have to double click on it to execute the project. So double click on this run server.bat file. Here, manage.py file is compiled. Now, Django framework, it will host the application at the local address, which is the host and the port. Now we have to copy this local link provided by the Django framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. You can paste it in any browser if you want. Paste the link at the end, type index.html and click on enter. So this is the web page of the project, which is displayed in the browser. And this is developed using Django framework. So here in this homepage, we can see two different links. One is new user sign up here and the other one is user login. So before logging in as user, if he has not signed up, he has to sign up and then he can log in. So let's sign up first. Click on new user sign up here link. Provide all the necessary details. So the username would be Ramesh. Give his password, contact number, email ID, give his address, and now click on submit. So sign up process of Ramesh is completed successfully and he can log in to perform all the activities. Now let's log in. So click on user login, provide username and the password. So the username is Ramesh. Give his password and click on login. So user Ramesh, he has logged in successfully. This is his dashboard where he can perform all the tasks. So here in this dashboard, we can see various links. One is ES offline key generate, data collection, CS poly aggregation, CS CRT aggregation, and computation graph. Now let's generate keys for the users. So click on ES offline key generate link. Here we need to simulate users. So let us simulate 20 users. So click on submit. And here we can see a table displaying the generated keys. Here the first column contains the user ID and the second column contains the generated keys. So for the user one, this is the key generated, and similarly for user two, this is the key generated. In the same way, for all the 20 users, keys have been generated. So now Let us generate the IoT random data. For that, we have to click on random data, data collection link. It is buffering, it will take a while. So here we got the encrypted generated data. The data is generated and that too it is encrypted. So this is the data of user 1 and that too it is encrypted. Similarly for user 2 and also for all the 20 users. So for all the 20 users, data has been generated and that too it is encrypted. And this will be sent it to the cloud server. So now let's aggregate it using poly aggregation technique. So here we have to click on this CS poly aggregation so that cloud server will be able to decode the data. So click on this CS poly aggregation link. Here CS poly aggregation has been done. It means that cloud server can decode and recover the aggregated data using poly algorithm. So here in this table, we can see in the first column, we have the algorithm name and this is the user ID. So this was the data for this particular user one. And here the poly aggregated algorithm has decoded the data whose value is 130. Similarly for user two, this is the data which was generated and which was encrypted. So this is the value which was generated by using this poly aggregation. Similarly for all the users, it has been decoded the data. So here for all the users, for the 20 users, it has decoded the data. And this is the histogram, which is the estimated histogram. Here on x-axis, we have the number of aggregations and on y-axis, we have aggregated decrypted values. So now let's aggregate using the other algorithm, which is CRT algorithm. So scroll up, click on CS CRT aggregation. So click on that. So here we got the aggregated data. So here we have the algorithm name as similarly. So here we have user ID, this is the encrypted data, and here we have the decoded data by this CRT algorithm. So this is the decoded data. For all the users, it has decoded the data. So for all the 20 users, it has decoded the data. And this is the estimated histogram of this aggregated data. Now we will click on the computation graph. So scroll up. So click on computation graph. So this is the computation time chart where on x-axis we have number of aggregation and on y-axis we have computation time. Here, blue color represents the CRT algorithm and orange color represents the poly aggregation and this red color represents the cache aggregation. Now let's log out and log in as again Ramesh because I'll show you how the keys will be recovered. So click on this user login. Now give the username and the password. So username is Ramesh. Click on, give the password, click on login. He has logged in successfully. Now let's generate users. So let's give 5 more users and click on submit. So here 5 users are generated. Now let's click on data collection. It is taking time because initially we generated 20 users and now we have generated 5 users. So now it will aggregate all those users and give similarly. So here total will be having 25 users. Because keys, all the users, they will not be erased, they will be duplicated. They will not be duplicated. And here we will have all the users. Initially we had 20 users, right? And now we have generated 5 users. So all the 20 users and now 5 users, they will be aggregated. And here for all those users, data will be generated and keys, they will be recovered. So in this way, users, they can efficiently manage their IoT data through this project by generating and encrypting user-specific data, aggregating it securely using poly aggregation and also the CS aggregation algorithms, and utilizing cache memory to minimize the redundancy. Users they can sign up, log in, generate keys, and also analyze decrypted data, making it a comprehensive solution for secure data handling in edge cloud environments.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.